Chapter 2, Lesson 4 in Geometry, and I know it says Algebra here, but what we're going to do in this lesson is give reasons for the things that we've been doing in Algebra all along. And again, the major focus of this course is giving reasons for what we do and why we do what we do. I don't know if that makes sense. Why we do what we do. I guess it makes sense. But anyways, and so all these things that you've been doing over the years in algebra, we want to be able to give a reason then. So we're going to give a step-by-step reason. Well, how did you get this? And then the next step, well, what did you do next? And what did you do next? And so it's a step-by-step process of reasoning in algebra. And this should help your algebra skills because it does show you step-by-step how to solve equations. So it's a review of that. And then hopefully maybe we can clear up some things that maybe you have trouble with as you're going along. So we're going to look at reasoning in algebra, and then we'll look at some different properties of congruence in the next video. So in geometry, we accept postulates and properties as true, and we use inductive reasoning to prove other statements. And some of these properties you accept as true are the properties of equality from algebra, and these are listed below using these terms. So you have all these properties, and these are what you do when you're solving an equation. Addition property is when you add the same thing to both sides. Subtraction property is when you add the same or subtract the same thing from both sides. Multiplication property is when you multiply both sides by the same number. Division property is when you divide everything by the same number. Now the reflexive property we will use a lot as we go through the year. We're not going to do it much in this lesson, but that means something is equal to itself. And you can imagine looking in a mirror, what do you see? You see yourself. So it's a reflection of exactly who you are. So that would be equal. Another one that I use quite a bit is the symmetric property because as a matter of convention we like to have things on the left, or at least I do, the variable, and so we can switch those around without changing it as long as we switch both sides. Transitive property is a favorite of Logan Lundquist, and we'll talk more about that in the next video. And then the substitution property we use quite a bit because we're starting with geometry equations, and then we're substituting in the the expressions that they gave us. We've been doing that already this year, so again we're just going to give reasons. And then the distributive property, if you have a number outside of parentheses, you can distribute that number. So these are properties that you're familiar with. Now we want to give a step-by-step reason of how we're doing those. Now we use deductive reasoning every time we solve an equation, and you can justify each step that you make with a postulate, a property, or a definition, like we've been talking all year long. So here's an example or a few tips to remember. The equation that you begin with, again, must come from a geometric postulate, definition, or theorem. We've talked about that a lot so far this year. So that first step, that first equation, has to have a geometric postulate, definition, or theorem justifying it. Now this is very important, the difference between simplifying and properties of equality. If you're working on one side of the equation, in other words, you're just looking at the left side of the equation and you're adding some like terms together, that's called simplifying. Or if you're distributing on one side, that would be distributive property. If you're working on both sides of the equation, meaning you add the opposite to both sides, or you multiply the same thing on both sides, or divide by both sides, then that's an algebraic property of equality. So very important to make that distinction. If you're adding numbers on one side, that is not the addition property. That's simplifying. The addition property is when you're doing the same thing to both sides. So I'll try to point that out as we move forward as we're looking at some of these. So we're going to do a number of examples. So here I've written what we just talked about. So here they've written out the step you have to justify. So how do we get this first equation? Well, by looking at this diagram, we know that AOB plus BOC is equal to AOC. That is the angle addition postulate. That's that geometric equation that we arrive at. Then how do we get from this expression to this one here? Well, we do that by substituting in now the values that we have in the diagram. Now we're going to do our algebraic properties. Now the first thing we do here is we add x and 2x. That is not the addition property even though we're adding, because we're not adding on both sides of the equation. We're only adding on this side, so that is simplifying. Okay, and it doesn't matter whether you're adding or subtracting. If you're only doing it on one side, it's simplifying. Then next we're going to subtract 10 from both sides, so that would be the subtraction property. And then the last step is to divide by 3, so that would be the division property of equality. So each step is justified by either a postulate, theorem, or definition from geometry to begin with, and then everything else is an algebraic property. All right, let's do another one. Fill in each missing reason. So we're LM bisects KLN, so that's a given. So now how do we get this is equal to this? Well, we get that because we know this. So this is because that's the definition of a bisector. What is a bisector 2? It cuts things in equal parts, which means these are equal parts. Now how do we get from these letters with these now expressions? Well, we substitute in, right? And then we're going to subtract 40 from both sides, so that's subtraction property. And then we're going to divide by 2, so that would be the division property. So again, we're always going to start with a geometric postulate, theorem, or definition, and then beyond that is going to be an algebraic property. Alright, let's look at one we've done before. So here's the diagram. So what do we know when we have this? Well, we know that AB plus BC is equal to AC. How do we know that? That's the segment addition postulate. So now that we know that, we substitute in the values that are on the diagram. So then how do we get from 2y plus 3y? We're adding, but it's on the same side. We're not moving anything over, so that's not the addition property. That's simplifying. And then we are going to add 9 to both sides, so that would be addition property. And then we're going to divide by 5. That would be the division property. Okay, every step has a reason. Whoa. All right, now here they solve for n, and all we are given is this diagram. So again, we start with a geometric equation. We know that xz plus cy is equal to xy. How do we know that? Segment addition postulate. We then remove or substitute in these values up here for these letters. So we substitute, that's substitution property. We're then going to multiply this 3 to get rid of the parentheses, so that's to distribute. We then have these like terms, 3n and 3n, on one side that we're adding together. So again, we're not adding something to both sides, we're just adding like terms on one side, so that's simplifying. Then we're going to subtract 12 from both sides, so subtraction property. And then we're going to divide by 6, so that would be the division property. Okay, so these are reasoning in algebra, so we're using properties. To begin with, we're using geometric postulates, theorems, and definitions, and then from there we're using algebraic properties that we've used in order to solve these equations. Alright, so we'll take a look at some congruence equations in the next video, but that should get you started on this one.